Hi, I'm Li Yuanpan from the Australian National University. I and Arif will present our work, Dual Pixel Exploration, Simultaneous Depth Estimation, and Image Restoration. First, we will introduce defocus and dual pixel sensor. Then, we will go to our DP model and the simulator we presented. After that, we give a brief image of our DDD net. The experiment and result are shown at the end. An aperture is the opening within a lens that controls how much light hits the image sensor. The size of the aperture will decide the depth of field. The depth of field is the area that objects are in sharp focus. If an image has a large depth of field, both the foreground and background are sharp. If an image has a shallow depth of field, where the background is completely out of focus, we call it the defocus blur. Now we will talk about the dual pixel sensor, namely the DP sensor. The DP hardware works by splitting each pixel in half and creating an image pair in a single snapshot. Each pixel is, in fact, built with two independent photodiodes. This technique was designed by Canon to aid autofocusing. For autofocus, if the signal from the two diodes slightly shifts, it means that area is not focused. Then, by computing the amount of signal difference, the lens will adjust to achieve focusing. As the DP sensor simultaneously captures two images, besides autofocus, it is used in depth estimation, defocus deblurring, reflection removal, and shallow depth of field image synthesis. However, the disparity of the two will only appear in the out-of-focus area, while the in-focus area is with zero disparity. Though Canon and Google provide DP data to customers, both sensors are hard to get the associated JT information, such as depth. In this work, we propose a theoretical DP model and the first DP simulator to overcome the lack of dataset. Then, we propose a DDD net to estimate the depth and restore the image jointly. The DP sensor is modeled as an ordinary camera with a lens satisfying the same lens model. Consider a world point X. Rays from the point X pass through the aperture AL and are focused at X prime. They meet the focal plane at the depth F, covering a region AL prime, geometrically similar to AL, which is same as the right wheel. For each point in an image L, the intensity of a pixel is spread over regions on the sensor plane. The size of a region is determined by its depth and other camera parameters. More details can be found in our paper. Based on our DP model and with the integral image, we built the first DP simulator. The simulator can work with an existing RGBD dataset, any existing RGBD dataset, such as NYU dataset and the Mid-Berry dataset. With the DP model and the dataset from our simulator, we built our DDD net using the concept from our simulator. We add a reblur loss to regularize the restored image and depth map in training. Here are the results on our real dataset, on our DPD blur dataset, on our DPD depth dataset, on our synthetic dataset. Our approach achieved competitive performance compared to the state-of-the-art approaches. This is our team. Thanks for watching. Code can be found on our project page.